Alright, so on this 2003 Dutch Star, these house batteries are dead. See, they're over 4 years old now, and my customer wants new ones. Trying to make this a quick video. We can check our voltage real fast. So if we look on one battery itself, almost half a volt. Huh? Not very good. And the chassis batteries. Sorry, it's very difficult to do this one-handed. We're at 12.6 there. So these are 6-volt batteries. Whenever I'm changing out any batteries, I always take a picture, so I know exactly how they were hooked up. Even though I've done this thousands of times now, even though I have a diagram right here, you never know what got added or got changed. Now these are 6 volts, but this still is a 12-volt system. These are the chassis batteries. There's two 12 volts, but they're wired in parallel, so it's always 12 volt. Now on the 6-volt side, you have 4 6 volts, and they're wired in a series parallel. So how I always think of these batteries is you're making 2 6 volts to make one 12 volt, and you put those two 12 volts together. So there's a positive and negative on this 2 batteries right there. You can see the positive and negative right there are connected. So this becomes the positive terminal, and that becomes the negative terminal for this great big battery now. So these 2 batteries made one big battery. It's the same thing back there. And then on this side, you have the positive going out to the house side, and just the 2 positives are hooked up together, and that's probably the inverter. So that's the series here, and this is the parallel between the 2 seried batteries. Even if you don't know how that works, it's always best, if you're going to do batteries, take a picture so you know how to hook them up. Of course, you do series, you're doubling you're adding the voltages together. When you're doing parallel, you're adding the amperages together. That's why they do a series parallel on a 12-volt system like that. All right, so let's go ahead and get this disconnected. I already took my picture. One thing I did forget to say, you have a negative ground. So you always want to disconnect the ground first. It's not that you're going to damage anything for the most part, other than every single part of this metal chassis here is ground. So if we try to hook up, do the positive side first, and we touch the metal surfaces anywhere, we're going to short out the system, just like putting this cable to that cable. But if you are doing ground and you hit anything metal with your wrench, you're not going to short out because you're already on ground. So that's why you always want to do ground first. And always count your cables. Sometimes they fall back here on these Newmars and you can't see them and you forget them. Also, you can see some corrosion. We'll have to take these cables off and clean them up a little bit. Now, I have absolutely no loyalty when it comes to batteries. That is to say, I don't care what batteries you want to put in a motorhome. I think unless they're lifelines or, I don't know, lithium ions, you're only going to get 3 years out of them, best case scenario, no matter what. So if you get the more expensive lifetimes, yeah, you might be getting 5 to 7 years, but they usually cost 3 to 4 times more than your standard batteries, so I'm not sure if the money actually adds up. Durability on lithium, we haven't really figured that out yet. They're still pretty new on the market. Without a doubt, they're the best, and I mean, if you can do it, do it. My biggest thing with batteries is you want to get batteries that aren't some sort of local generic battery, because RVs are going all across the country, and in the US they're going to be going into Canada and into Mexico. So you want to get a battery that if you need to get the warranty approved on or replaced on, you don't have to go 2,000 miles back to where you got them. And in my shop, I just use Napa batteries. I think the dirty little secret anyways is there's like only 3 battery manufacturers in the North America, and I think most of them are in Mexico. They just slap different names on them. Yeah, they have different specs and different I guess, quality to them. My own opinion is I've never seen a Walmart battery last more than 2 years. That's the only battery I won't recommend. So normally with these 6 volts you get a nice strap like this and you just put it on the hooks, but I guess those little hooks were in the way of the cable, so those got cut off. So I guess I'm just gonna have to manhandle these out. Do resist the urge to lift up by this battery vent right here. That'll just pop off and then it'll drop on your toe and then you'll be in a lot more pain and wish you had somebody else doing this. It's always a good idea to service the battery tray a little bit. This is going to get acid on it, so there's no real reason to make it pristine. If you do paint it, yeah, you'll feel good about it, but it's just going to peel off. This was powder coated, and once the acid's in there, it's kind of in there until you completely scrub this thing down, sandblast it, and go again. So we'll just do a little bit of battery maintenance. I'll get some terminal cleaner. All this is it's also a neutralizer, so it works out pretty well. All right, and then I'll let that sit for a little bit and we'll clean that out. And then while we're waiting, we'll go service these battery cables. Yeah, because I'm at the shop, I'll just be using my wire wheel brush here. Alright, so we'll get the rest of that going, and then we'll put some batteries in. Now for these battery cables that I can't just remove and take the wire brush, I'll just get a wire brush on my drill, holding the drill with the pair of pliers, or the cable with the pair of pliers, like that, and then I'll clean them off. You don't want to hold them with your fingers because that wire brush always grabs your fingers. This right here is just a battery temperature sensor. Yours might vary. You may not even have one. This is just for units with a bigger inverter. Sometimes actually have a terminal, so you go straight to the battery. It doesn't carry any voltage on that terminal. It just senses the battery temperature. So you'll see that one was just wedged in between them because normally it's stuck on, but it's a one-time stick, and they don't stick on plastic very long anyways. So let me get those cleaned up, and we'll start getting the batteries in. So these batteries did come with new nuts, which is good. But the old nuts that were on there, they will fit, and I like these nuts a lot better because these are washer-headed nuts, and they're somewhat serrated as a self-locker. They also had crush washers, these lock washers. I don't ever like putting these on batteries. One, this bolt that's on that terminal is just encased in lead, and they can only take so much tension before they actually just break the lead. But also that becomes a secondary, or actually gives you 2 more surfaces to corrode and keep from good contact with the battery to the or the cables to the terminal. And then of course with the washer head, it spreads out the load and holds onto that cable a lot better. So I like these much better. If you have them, I'd use those instead. Just clean them up and use them. And of course, I like to make sure the actual true leads are hitting the terminal itself, and then the jumper is going to go on top of that cable. That's just my opinion on things. But of course, RVs being what they are, they always make my life more difficult than they ever need to be. So these batteries are a little bit different design, and so that cable won't make it. If they were there, that would have fit. So now I have to make new cables. Alright, I have to go get some parts. Well, when it comes to making cables, I just lay them out how I think I'm going to do it. I'm going to go ahead and strip this back so I can put a ring terminal on. I just found my nearly destroyed, these are actually Mac, I think, cable cutters. Do a good job of scoring the insulation, then I slice it with the knife and peel off the insulation. Of course, that'll just slip in right there, and we're going to crimp this thing on. I just use my battery cable crimper. Alright, so we're just going to slide it in right there and hit it with a hammer. Alright, so there we go. It crimps it on that side with a little dimple, but it also puts a wedge down below and it crimps it really well. You don't have to go crazy with it. It'll crimp it. And it's the right size, so let's see how it fits. All right, so that's in place right there. I'll just bring this over to where I think it needs to be. Line that up, and that looks about right. I'll just make a mark right there and right there. Cut it right there and strip it to right about there. All right, well, that battery cable worked out perfectly, and it'll fork on the other side too. Now, I am not convinced that putting heat shrink or electrical tape here is really that useful. Yeah, it makes it look prettier. I won't deny that, but it doesn't really protect it from corrosion as much as you think it will. Neither one of them are completely weatherproof. And what happens is moisture does get in there, and because it's covered, you can't see it, and it doesn't dry out so fast. I've had battery cables that have been corroded this far up inside the insulation because it just creeps its way in. So I'll still put probably loom over the top of this so that it does protect the cables from a little bit of wear, but that's about it. I'll make finish this one up, make the other cable, then we actually put these battery cables back together. Now it'd be best to tighten up these before we do the grounds. That way, again, once we hook those up, it'll be hot. And then with that one, we should be all tightened up. Check all our connections, make sure nothing's loose. I do like to at least spray it with some terminal protector. It's a little bit more than red spray paint, but helps neutralize the acid a little bit. It keeps things from building up. Also looks, I guess, a little bit more professional. All right, let's check the battery voltages. Not that I would normally check batteries this way. So if we're checking the individual cell here, our individual battery, 6.3. Okay. So let's see, we're on positive terminal there, negative terminal there. We're at 12.56, 12.66 fully charged. These are a little bit discharged, I guess. But let's go ahead and start the engine and see if we're charging off the engine. Good news is the step's working. It wasn't working before. This battery's on. All right, Newmar has a bird system in it. Bird is a bidirectional isolator relay delay, just an acronym. So there's a time delay before the engine will start charging the house battery. That way it's not an instant load on the alternator for both the chassis batteries and the house batteries. It gives it time to ramp up. And if the house batteries are so low that it's taking amperage or too much current away from the chassis battery and causing problems, it'll shut off that charge so that it doesn't try to charge the house batteries and keeps the charge just for the chassis battery. It's important to remember because I'm going to be doing a different system using a bird pretty soon. Alright guys, bad news. We're not charging the house batteries. I don't think you can hear me very well, but this charge solenoid is bad. Because that's just how life goes, I guess. That's the bird I was telling you about. That's the charge relay, so that should be house battery power there. This is chassis battery down below. Chassis. And we're definitely, this is trying to turn that solenoid on. I'm just trying to turn it on. So it looks like we got a bad relay. Well, that's pretty unfortunate. So I guess the simple job turned into quite a bit of work. It was just 4 batteries. How hard is it to change out 4 batteries? I guess the next check is make sure that the inverter's charging the house batteries, because that should always be the thing. The bird should be, that's the bidirectional part of it. It should allow the inverter to charge the chassis batteries, but that charge solenoid is not working. Okay, let's start the generator. There we go. It'll take a minute for the transfer switch to kick in before the inverter will kick on, so it's still waiting for AC. Alright, so we're bulk charging. Let's see what we got on the batteries. Alright, so we're getting 14 volts there, so that's good. That charge side's working. The alternator's working. It's just the charge solenoid that's not working. Let's go take a look. Of course, now it just so happens that I have a charge solenoid that I was going to be using on another job, so I'll just order another one and get this one coming. This is a pretty common one. The one that's on this rig is a White Rogers. This is a Trombetta. They're virtually identical. These are continuous duty rated, so you need to make sure it's continuous duty rated, not intermittent. This is the only place in an RV where the two sets of batteries actually link up. In years past, they used to be called battery isolators. They were a big blue looking thin heat sink looking guy. But this is a charge solenoid and your auxiliary start. So on a lot of RVs, you'll have a battery boost, just like that, or auxiliary start, where you can start the motorhome engine with your house batteries in case your engine batteries are dead. This is what that's turning on. It's linking the house batteries to the chassis batteries. As you can imagine, especially on diesels, they pull a couple, over 1,000 amps on that starter. So if you're continually using your auxiliary start to start your engine, you're going to burn the solenoid out. But also, just given time, these burn out because there's just a plunger in here that connects those two points together with like a copper washer, and it starts to get overheated and burnt out. So that was my long-winded explanation. Let's change this out and see if we got charge again. That would be power from the battery. We hooked up that cable already. This goes to the charge, so even if the battery disconnects off, it's always charging the batteries, and vice versa. And this is coming from the chassis battery, and this is going to your bird, bi-directional isolator, relay, delay, and then the other side of the coil is just going to ground. So it's pretty straightforward. It's just 4 terminals and 2 screws. So let me just get this swapped out real fast. All right, just like that. So this is the ground. Got ground down to the bird, and then ground's going over to the disconnect system for ground on that. This red is a control wire from the bird that activates the charge solenoid, whether the chassis batteries are charging or the engine batteries are charging. The shallow wire right here actually goes to that battery boost switch on the dash. So this is what you're still activating off that switch. Now we can start the engine and see if we're charging. All right, so if you can hear me, got the engine running. I'll put that back on there. And look at that, we got 14 volts going to the house batteries with the engine running, which is what's getting to the chassis battery. Let's turn the engine off. And let's start the generator again. And let's wait for the battery charger to kick on. All right, we are bulk charging again. Let's see what's going back in the batteries now. So now these should be charging because they're hooked up to the battery inverter. So that looks right. So now the engine battery should be charging, and they are. We did it. All right, guys. Well, so there you have it. Well, it's supposed to be a quick video showing you how to change out some 4 house batteries turned into battery cables and a battery charge solenoid. The bird system, like I said, we might be revisiting here shortly. Newmar used it pretty exclusively. Some Fleetwoods, a lot of Thor products. Winnebago did not ever really use it. So Thor, Damon, Monaco, on some of their coaches, they had a bird built into their battery control center in the back, and a lot of Fleetwoods have a battery control center with a bird system, but not the Intellitech bird system that this one has, but a very similar one. Works on the same principle. So there's a bad solenoid. It's a pretty common problem. So the big lugs are the battery, and the 2 small ones are the coil that activates the plunger or the solenoid. I hope you guys learned something from that. If not, at least I got it done. Thanks a lot. And you know what? By the way, I'm really deeply encouraged by the amount of subscribers that keep, I guess, subscribing to the channel. I did not even remotely think that that'd be possible. I'm pushing 1,800 now. So it's a heartfelt thank you. I know this last month I haven't been putting out too many videos. It's just been an incredibly stressful, busy month for me. And I'm doing my best to change things around at my shop. I got a lot of things coming around and a lot of different choices to make. So again, thanks for watching, guys. What is this? Yeah, 3-aught. Go get some parts and come back. Yeah, I guess maybe I should have checked the voltage before I sprayed it. Ah, yeah.
Bi-directional isolator relay delay.